today our lesson is all about polynomial function sketching. For our learning task 2 on page 10, we will describe the properties of the graph. F of x is actually dy. We can write this one as y equals and this expression here. So A, what is the standard form of our function? When we say in a standard form, the exponent is written in a decreasing order. This function is already in its standard form. This is the most important, the leading term. What is the leading term? That is the highest degree of the exponent. The highest exponent is to the fourth. So our leading exponent here is x to the fourth. Okay. What does this leading term tell us? If the leading term exponent is even, and this one is positive, then our graph, the ends of the curve, this one is even. It means x squared, x to the fourth, x to the sixth, x to the eighth, okay, and so on and so forth. And this one is positive. Our curve on the left will rise up. The curve on the far right will rise up also. So that's the end of our curve. We can have our curve here, but the far left and the far right, they will both rise up if this one is positive and this one is even. What about if this one is negative? For example, we have negative x squared or x to the fourth. Then our curve will be like this. This one is 0. This one is the 0. This one will curve down here. It will fall. And on the other side also it will fall. That will be the endpoints of our curve if this one is negative. Of course, you can have this one as x to the fourth if you want the same thing, and that is even. What if the leading term's exponent is an odd exponent? Say x cubed. So if you have x cubed, we have x to the fifth, okay, x to the seventh, okay, and this one is positive, then the endpoints here, the endpoints will be on the third quadrant. It is falling, or it's coming from below, going up. And then here on the first quadrant, it is rising. What about if you have a negative here? If you have a negative there, so you have negative x cubed, x to the fifth. So here, the end curves will be rising here and falling in the fourth quadrant. So there are 4 to determine the behavior of the endpoints of our curve. It's from the leading term. So you have even exponent and this one is positive, so both ends will rise up. If this one is even but the sign is negative, both ends will fall. They are falling down, like going down in the third and the fourth quadrant. Now if the exponent is an odd exponent and it is positive, on the first quadrant the end point is rising, in the third quadrant the end point is falling or going downward. If that one is negative, then in the second quadrant the curve endpoint is rising up, and on the fourth quadrant endpoint is going down. So our leading term here is x to the fourth. So we're going to write here the leading term is x to the fourth. Now we are going to sketch the endpoints here. Have the 0 here. We know this one is even, so it will go up because this one is positive. So the far right end will go up here, and the far left end will also rise up here. And that one. See, here is the 0 or the x-intercept. and its multiplicity. Okay, let's have multiplicities. So here, let us factor this one. We will write this one in factored form. So I have x to the fourth minus x cubed minus 2x squared. Now we can try the greatest common factor. Second one, we can try factoring by grouping, but we cannot group this one because we have only 3. And the last one is the hardest, in which we are going to use the scientific division. So here, let us factor. So here our GCF is x squared. So we have x squared, and then this one will be x squared minus x3 over x squared is x, and this minus, and then we have the 2 here. Okay. Then again, this one is factorable. So we have x squared. So we have this one is minus. So one is positive, one is negative, square root of x squared. We have x here and x here. We have factors of 2, which is, this one is negative 2 times 1. So we have these factors. Let's have the 0. Now this one, x squared, x cubed. This one here, our x is equal to 0. Okay. This one, x plus 1 is equal to 0. Therefore, x is equal to negative 1 here. And x minus 2 is equal to 0. Solve for x, transpose. And x here is equal to 2. Here class, the multiplicity of x squared, this one is 2. So the multiplicity here, multiplicity. Here is 2. It means it will bounce. When that one is 2, it will bounce on the 0, bouncing. Now, x negative 1, multiplicity is 1. So here, it's 1. What will happen there in the x equals negative 1? It will just pass. So it will just pass here. X negative 2, multiplicity is 1. So it will also just pass. Now we are going to sketch our graph. Let's have first the critical points. 0. So here, we have negative 1. So here, positive 2, here. Right, let us have the behavior of the endpoints. Far left. Far left. So we have here negative 1. So we can say that we can have that one here. And 2 can have. So that's the leading term. Behavior of the endpoints. After that one, now let's have negative 1. Negative 1. The curve will just pass. Okay, will just pass. So from here, we'll just pass here. And then the 0. So on the 0, because the multiplicity is 2, it will bounce. So on the 0, it will bounce here. It will not pass. It will just bounce. So here, we can have bounce. Do not pass. Okay, just bounce here. And the second 2 here, where's the 2 here? It will just pass. So here, it will pass here. So draw a smooth one and pass here and connect it there. So this is the graph of our polynomial function. So how many turning points do we have here? We have 1 here, 2, and 3. So n is equal to 4 minus 1 is 3. So we have 3 turning points.